Welcome to Part 7 of Variable Speed Injection Mixing presented by Taco. I'm John Barba, and if you'll recall, back in Part 6 we explored injection mixing using Taco expandable relays and the PC705 injection mixing control. Another option is the subject of Part 7 of the series. It's the Taco Radiant Mixing Block. To make the injection piping and wiring even easier than it is with the PC705, let's take a look at the Taco Radiant Mixing Block. This unique product has the injection circulator, the Radiant System circulator, all of the injection piping, the injection control, and the wiring, all in one ready to go right out of the box assembly. All you need to do is hang it on the wall, pipe up the injection legs, connect the Radiant to the outlet side, and plug it in. With the Radiant Mixing Block, you'd basically replace all of the piping you see here outlined in red, along with the injection circulator, the Radiant System circulator, the closely spaced tees on the Radiant side of the system, as well as the injection mixing controls with this. A single Radiant Mixing Block will replace all of that piping and all of that wiring that you would have to do if you pieced together the injection mixing station on your own. The mixing block will save you a considerable amount of installation labor and wiring labor, and since it's already piped up for you, you can be assured that the job will always be installed properly. Here's a 2-temperature radiant heating job. There's a large primary loop running above these two piping arrangements. You can see the two injection circulators. Both are wired into PC705s with single zone expandable relays. You can also see the Radiant System circulators, which are also wired into the single zone relays. Not a bad job, but there's an awful lot of pipe here and lots of wire and a little bit of confusion as to what everything does. Now here's the exact same job repiped with Radiant Mixing Blocks. Note the wiring appears to be much simpler and much neater, and the piping all looks like it makes some sense. You don't have to spend half an hour trying to figure out what goes where and why if you were called in to look at the job. The supply piping to the Radiant Mixing Blocks is on the left-hand side. You can see it coming down from the large primary, while the system piping is on the right-hand side, and it's heading off to remote manifolds. Here's a look at the guts inside the Radiant Mixing Block. It's a cast brass construction, and on the left-hand side you have the injection supply and the injection return connections from the primary loop, and on the right-hand side you have the Radiant return on the top and the Radiant supply on the bottom. The mixing point inside the block is at the top of the unit, where the hot primary water mixes with the cooler Radiant return water. Then some of the tempered water will be sent back to the primary by the injection circulator, and the system circulator at the bottom will send what's left back out to the Radiant system. And for the record, the injection circulator is a modified Taco 006, while the Radiant circulator is a modified Taco 00R. Now here's a big job with a lot of Radiant Mixing Blocks in action. We have a modulating condensing boiler arrangement up on the left-hand side. These ModCon boilers are taking care of the high temperature zones, and if you look closely you can see 5 Taco EBV zone valves in the center, while 5 Radiant Mixing Blocks will handle 5 distinct water temperatures for the Radiant system on the right-hand side. In this example, the boiler will provide full outdoor reset for the high temperature radiation, while each Radiant Mixing Block provides separate and distinct reset for each of the Radiant applications. Here we see 3 Radiant Mixing Blocks piped into a primary loop for 3 separate Radiant water temperatures. As with any primary-secondary piping arrangement, you want to take the hottest water application off the primary first, and then work your way down to the lowest required water temperature. The water temperature in the primary loop will drop after each secondary, again, so it's best to start with your highest water temperature first and then work your way down so the lowest water temperature is the last one taken off of the primary before it returns to the boiler. Now here's an interesting looking application. We show a primary-secondary piping arrangement with 3 high-temperature secondaries taken off first. And then we have 2 mixed-temperature Radiant secondaries with Radiant Mixing Blocks. The interesting thing here is that the installer has decided to zone his first Radiant system, that's the one in the center of the picture, with circulators. Note what appears to be a secondary primary loop using the Radiant Mixing Block system circulator as another primary circulator. Then 2 other circulators are piped off of that primary. Also note the 6-inch maximum T-spacing throughout the job. In this example, those other circulators are the Radiant System circulators, while the Radiant Mixing Block system circulator will fire whenever any of those 2 zones call for heat. The injection circulator will do its injecting regardless of which zone is calling. The second radiant mixing block on the far right-hand side appears to be set up in a conventional manner, with the system circulator serving as the radiant circulator for a remote manifold. And here's a line drawing diagram of how that system would lay out. Note the primary loop with the highest temperature applications coming off the primary first, and then the radiant mixing block for the mixed water temperature. Again, see how the RMB system pump serves as another primary circulator for another mini primary loop. Then two zone circulators handle the radiant from there. You may use this application in an instance where you may want to zone your radiant manifolds with circulators as opposed to zone valves or manifold actuators. You may also use this application with multiple manifolds off each radiant circulator, with each manifold zoned with either zone valves or actuators. Or you may want to do this if the demands of those radiant systems exceed the capabilities of the modified OOR circulator. Well, that's all for part 7. Please join us for the 8th and final part of the TACO presentation on variable speed injection mixing. And in that section, we're going to take a look at a low-cost injection mixing option that doesn't use an injection circulator.